We will start first by talking about post-processing in Fluent. The tools built into Fluent have the advantage of letting you quickly review the simulation. Because all of the data is still in memory of the solver, it's easy to stop the simulation and check the results, and then you can either modify something in the case setup or continue with the calculations, and all of this without having to wait for any file reading and writing operations that would be necessary if you were using a different application. The picture here shows an example of the creation of temperature contours, and you'll be familiar with this if you've done any of the workshops up to this point, and we'll provide more details about the kind of operations you can do in the next slides. Post-processing in Fluent operates on surfaces. Results can be plotted or reported on existing surfaces that are present in the model, or you can also define new surfaces within Fluent. Commonly used options for surface creation are a planar or cylindrical surface cutting through the model. You can use isosurface based on constant mesh value of x coordinate, for instance, to make a plane, or use a radial coordinate. Isosurfaces can be used to create 3D surfaces that show where a given value exists, for instance, if you're looking at temperatures or concentration. Line surfaces can be created for use with XY plots, and point surfaces can be used as a sampling point to show values at a particular point in the calculation. The figure on the right shows the creation of an isosurface. The first thing you do is go to the Surface menu and select Isosurface. Then you select the variable you want to create the surface of. Here it's temperature. You click Compute, and then use the slider bar to get the value that you want, or just type it directly in the field, and click Create. Fluent allows you a great deal of control over the rendering options, and this allows you to control the look and feel of the post-processing. This includes views and display options like where to position the camera, color maps for contour and vector plots which can be customized and or modified. Shading and lighting can be used to make attractive looking surfaces. Plots can be annotated. Surface manipulation like offsets can allow you to do things like create exploded views. And fairly elaborate scenes can be composed using plot overlays, different coloring of surfaces, shading, and transparency. An example is shown here, where there's an overlay of a contour plot and a vector plot, and some of the walls have been made transparent to give you the impression that you're looking from the outside of the object into the interior. There's also the possibility to create scene animations and make fly-throughs. The menus for the various different rendering options are found under the Display menu in the main menu bar. You can change the mouse button functionality in Fluent by going to Display Mouse Buttons. If you prefer the workbench mouse behavior, then you can select workbench defaults in the panel. If you choose the Fluent default settings, then these are slightly different depending on whether you're using the 2D solver or the 3D solver. In the 2D solver, the left button translates and pans, the middle button zooms, and the right button selects and probes. In the 3D solver, the left button now rotates about 2 axes. The middle button still zooms, but if you middle click on a point in the screen, it will center the point in the window, and so that way it acts like a translate capability. And the right button selects and probes. You don't have to use the defaults. You can customize the functionality of each of the individual mouse buttons in the panel. You see that there's something here called mouse probe, and you may have seen that if mouse probe's enabled and you click on something with the mouse probe button, then it will display information about the object and flow field data near the location where you clicked. You can control the amount of information displayed by the mouse probe by choosing either the long description or short description options in the probe field. It's common to want to plot data from your CFD solution, and in Fluent you can make XY plots of solution variables, histograms to illustrate frequency of distribution, and fast Fourier transforms of time-dependent data signals. You can also read other data files in with experimental and or computational results in order to compare with the current results in your case. In the example on the slide here, there's a plot of temperature versus x-coordinate on a particular surface. And so you can see that you can plot any variable on any surfaces, or you can even select multiple surfaces for plotting. Fluent also has tools to report quantitative numerical data for analysis. These include flux reports, which show the total mass or energy flow through a boundary, and so this is a useful way to judge whether the solution is converged. Surface integrals, which show the total, average value, maximum or minimum values of any quantity on any surface, and also volume integrals, which are analogous to surface integrals, except for they work on cell zones rather than on surfaces. You can see that the reporting types here are similar to what you have in the surface integrals panel.